Okay, we're going live. Hello everyone, hope you had a great lunch break and now you are feeling better and better with the Dev Days Europe Conference 2022. Stay with us because we have a lot of interesting topics, a lot of interesting talks, and just make yourself comfortable and enjoy. I just want to mention that at the end of the session we will have time for Q&A and you can write your questions in the Q&A chat whenever you have one. Keep in mind also that you can win ebook because our knowledge partner pact will be giving away 20 books to the most active conference attendees. Kindly urge you to participate and be active, rate sessions, leave comments, ask questions, and nobody knows, the winner can be you. Let me introduce you our speaker for the session. It's Sebastiano Galazzo. Sebastiano is chief technical officer now, and he's a winner of 2 artificial intelligence awards. He has been working a lot in the AI and machine learning for the last 20 years, designing and developing AI and computer graphic algorithms. He's very passionate about AI, interested in technologies focused on image and natural language computer vision. He also received several national and international awards that recognize his work and contributions in those areas. And he is also the Microsoft MVP for the artificial intelligence category, international speaker. And one thing that he is very proud of is that he is a proud dad. This is not to mention. The topic is very interesting for today. It's called Deep Dive on Creating a Photorealistic Talking Avatar. It will be about creating a photorealistic avatar, speaking any sentence starting from a written input text. We'll be focusing on the autoencoders, and he will take you on a journey from the beginning with all the mistakes and tips learned along the path. So, Sebastiano, I'm giving the word to you. Good luck.
Thank you. So I'm going to share my screen. Okay, guys, thanks for attending my session. Thanks for the introduction. I guess that we can skip my first slide with my introduction. Anyway, here there are my contacts. If you want to write me or keep in touch in LinkedIn, I will be happy to help if I can. What about this session? Yes, of course, is talking about creating a photorealistic avatar, talking avatar. Please keep in mind that this is the summary of 2 years of research and development, and it's very difficult to make a great summary of this topic. So what we will do is to jump on the highlights of the project in order to allow you to figure out all the workflow. And if you need much more details of some process, please feel free to keep in touch with me again. So I will show you soon the result of our project. So I created a video for this event and I typed a text, an introduction text, and the AI made the magic rendering a video. So here.
Hi everyone and thanks for attending this session. This is the digital version of a real person, generated from a text, by a sophisticated AI, result of an intense year of research, development, and most importantly, great passion. Today we will talk about my creation. Enjoy.
Okay, so how I arrived to this result, I will talk you soon. But first, very quickly, let's talk about the application field of this kind of technology. This is a technology that works, let's say, in 2D because it renders a video. It's not a 3D, and there is a reason. And because it's a different product from a 3D architecture, because we needed an highest level of quality of the video, so it to be so real, it wasn't possible to reach this result using 3D technology. Anyway, field of applications, of course, a chatbot. So merge this technology with your customer care chatbot. Or, for example, one product that we created in my company was to empower landing pages for your e-commerce, for example. So let you imagine how it works, a standard landing page nowadays that basically is a big banner, and with this technology and an AI behind, able to make a good conversation, you can engage much better your customers. Of course, we imagine also home devices and also info totem that basically are that totem that you can find in shopping center or malls, providing information. And in this case, you can create something much more interactive. And why not also automotive? Because we were in touch with car builders creating supercars, and they wanted to introduce an avatar for their supercar. So I don't know if that will really happen, but anyway, that was the request, and then another field of application. So the workflow, we created everything from scratch, and I said everything. So from the footage, from the shooting, to the each line of the algorithm to the final result. And the first step is of course creating the data to be used for training the deep learning model. And then we created a format of our video. Basically, is 6 minutes, 6 minutes of the video, and we were able to do that because our a linguistic team of experts created a text containing all the vowels and the phonema of our language. And then with just 6 minutes, we were able to create something and not hours of training. And of course, we use the software like Adobe Premiere, After Effects to remove green screen and so on. And the second step is one of the most important, and talking about audio processing, and then created the data set after we can switch to train our deep learning model, of course. And then after creating our model, we can create our inference infrastructure and providing a service for that. And of course, we created something using Azure streaming service because we don't want to create something like Synthesia, that is a platform that is just able to produce a video, but we wanted to provide a full service. So an NLP engine behind, creating the avatar and the streaming service. So let's talk about audio processing, that in my opinion, as I told you before, is one of the most important part. So the goal was to start from a text and then creating the video. And the first step is of course a text to speech process, and for this step we used a standard text-to-speech, like it could be Microsoft text-to-speech, but you can use the service you want. So once we have the raw WAV, we can start using audio processing algorithms to manage it. We are talking about short time Fourier transform, of course. For people who don't know too much about that algorithm that was invented 200 years ago, basically what it does is to split our audio in small chunks, and we will see much more in details about the chunks and the size. But anyway, now you have to imagine that we will split our audio in small chunks. Each chunk is matched to a frame of the video that we created from the footage, and then we extract all frequencies of that chunk in order to use that information as input of our deep learning model. And so the AI will be able to reproduce the final frame based on that frequencies that are similar frequencies that we will provide in the future. Oh, sorry. Well, I said that we used all frequencies using a short time Fourier transform, but our brain works in a special way. What I mean, first, humans can detect sounds from 20 Hz to 20,000 Hz. But the human voice spread between 100 Hz to 3000 Hz, more or less for male. It could happen 5000 Hz for women. Of course, depends, but more or less this is the range of sounds. So the first thing that I have to keep in mind is that I don't need all frequencies, because if the voice led in this small range, all other information are useless and could impact in a negative way while training my deep learning model. So the first thing that I have to do is to cut useless informations. Say that is still not enough, because how it works over here works in a logarithmic way. Like for images, basically we are more able to catch differences in audio in low frequencies rather than high frequencies. Again, it is like how it works for images, where all information stays in low frequencies. It is exactly the same thing, except that here it works in a logarithmic way. And there is an algorithm that is named MFCC. This is something that is standard. Maybe 100 years ago was invented, and this algorithm, what it does is to process my frequencies, so of the chunk in this case, and it changes these frequencies, compress them like it works in our brain, so compressing much more high frequencies and less low frequencies. And that is also useful. Why? Because it shorten the amount of information that we have to use. Because more or less, in my case, I as parameter of my Fourier transform, I use a value of 5096 samples, and that we have to divide by 2, and so 2000 samples. In this way, using MFCC is not only much more accurate, but also we can reduce the amount of information of the input of my deep learning model. And for people that have a bit of experience on how machine learning works, they know that the more you are able to reduce the amount of information used in input, the better it is. Well, again, much more details on frequencies and the fast Fourier transform. We said that something about the size of the chunk based on some calculations on or based on the fact that the video has been shooted in 25 frames per second and the audio is 60,000 samples per second. Made some calculations, we get that the size of our audio chunk is more or less 40 milliseconds. 40 milliseconds could seem a very small value, but when you talk a normal conversation, this is more or less the time that you use to say a vowel, so a small sounds, and so it's perfect, it's fit perfectly for our goals. And also based on other calculation, we can use as length of our window of a fast Fourier transform this value that is 640. Now, one important thing is that Fourier transform and standard algorithms that you can find in the implementation of, for example, LibreOsa for Python users, basically they works overlapping these windows. But for our goal, that mustn't happen. So what we have to do is to avoid overlapping windows. In some cases, of course, but what I did after a lot of tests and a lot of research is to create the input of my model in this way. So basically, I center the window for my chunk, and I get one chunk before and one chunk after, and another input of my audio model is centered in the chunk, but with a wider window, using a Gaussian shape, of course. And in this way, again, this is the result of a lot of tests, a lot of failures, and I discovered that this is the best configuration that I'm going to share with you. In the first case, I use a smaller window, but with 3 chunks close together, and I organized that 3 chunks as an image. So using a 2D convolution, we will see after how it works better. This is more or less the representation of my audio input data. Well, let's go much more in details on the deep learning model. Or I used a configuration that is named autoencoder. I guess that most all of you know how it works. Anyway, a very quick summary. Basically, you have to imagine an autoencoder like 2 neural networks connected together, where the center part is named the Latin code. How it works? Let's say for commodity that the part on the left is named the encoder, and that takes the input of what I have to process, and using convolutions operations, it try to extract very important information of my input. And at the end, we arrived at the Latin code, that is a very small array containing the really important information of my input, that in this case is an image, but also could be an audio or whatever it is. In the same way, on the right part, we have what is so-called the decoder, that using an most specular architecture of the encoder, try to reconstruct my information starting from the Latin code. It's an amazing architecture and works pretty well for a lot of tasks. Anyway, here we are, this is the architecture of my audio encoder. So, as I told you, I organized the input, one input as a 2D image, and another input as 1D. And this is more or less the architecture of my audio encoder. Again, this is the result of a month of research and working 24 hours per 7, and this is the final result. And I will be happy to provide much more detail if you need about this architecture in a Q&A, or if you keep in touch with me. But we have not so much time for details here. But here I will share just the architecture. But what I can say to you, what I can show you is the final architecture that has something, let's call special. What I introduced is an autoencoder that takes so far 3 inputs. The audio encoder that has the architecture that I showed before, but also a reference image to help the model to reconstruct the face with a very high quality. I used residual blocks for that, and the skip connection, of course. But here what happened with fast attempts happened that basically the image information are far away bigger than audio information, and then they were too much for the Latin code. And so what happened was that they almost cancelled the information of the audio that instead was the most important part. So the solution for that it was my solution, of course, I'm going to share with you. Maybe there are other way to solve that, but what I did was to connect just the audio part of the encoder to the Latin code, avoiding to connect to the Latin code the image information, but using the image information just for skip connection. And magically things started working. Well, but how it works exactly, the reconstruction of the part that is animated thanks to the audio. So everything has been inspired by in-painting algorithm. That is the same technology that you can find, for example, in Photoshop called content aware filling, or basically the same the same technology that allows you to cancel unwanted objects in your scene, in your picture, whether it is people or objects. The same technology can be used, of course, to reconstruct faces using AI. And most of these deep learning model are trained using a very large data set in order to be the most general possible. But what happens if I use this kind of data set is that maybe it works very, very well, but what happened is that it reconstruct the missing portion very well, talking about image quality, but it will reconstruct using for sure how to say, the content that is not your. Let's imagine, for example, about thief. Being a general model, it will reconstruct your face, your missing portion, in a way that are unreal. So what I did is to use this approach, but trained with my own data set using the images coming from the shooting. And this is more or less the idea. So starting from a text, I use a text to speech to create my own audio. I process this audio, extracting frequencies for each frame, and then I use a reference video for the final result, where I mask the portion of my jaw and face in order to train the AI to reconstruct just this portion according to the new audio coming from the text that I want. Well, here, of course, is summarized everything, a summary, and here I spent a lot of months finding the perfect, or at least the best recipe that worked for me. And I realized that, for example, that the shape, the size of the mask impact a lot into the final result. So I worked a lot using another deep learning model, extracting landmarks. I used the DLib model, and to extracting my facial landmarks in order to create the perfect shape according to these landmarks. And for example, I realized that at the beginning, a much more squared mask was better than when we were close to the hand, were doing a fine tuning of the details, where I needed a mask that was a bit smaller and much more fitted to my face. So the final training is split into what I call the stages, and according to the current accuracy of my model, I switch several parameters, like one of the most important, of course, the shape of my mask. Well, I had to introduce something to change the input image, like a thin transformation. So I talk about rotation, translation, and a bit of zooming of my picture. as well luminosity or contrast. So changing the input helped a lot the stability of my deep learning model. If you don't use this kind of transformation, what happens is that the deep learning model learns too much how to reconstruct the missing portion. But what happened is that he knows that, for example, teeth are always in the same region, and that led to a model that is not able to reconstruct very well in all conditions your face. So this is very, very important that you introduce this kind of transformations. But also, not all transformations must occur in all stages. Again, I did a lot of research and realized that, for example, at the beginning, it's better to use much more translation compared to the end and stuff like that. Well, let's say now that we trained our deep learning model, and now we are able to do our inference. The output are frames, basically, because again, you now already know that we split our chunk portion of our audio in a way that are matched to a single frame. So we, according to the audio that comes from the speech to text, we produce the video, the frame, sorry, for that chunk. That basically is a frame. And here I use a tool that is very common and famous that need no presentation, that is named FFmpeg, to put everything together, audio and frames, in order to create our final video. Here is very important to enable optical flow option. This is something that I discovered and I want to share with you. What is optical flow? Basically, if you put in pause your Netflix series, for example, what you will see is that the background is perfectly frozen, but moving objects or people are a bit blurred according to their movements. That makes your video much more smooth. We want to do the same thing with our video, because my footage was in 4K with an high frequency rate, because I had to extract images from a single frame, and recording with high frame rate produces a final video again that is not so smooth. This is something that you can figure out searching on the web, a common feature of video producing, and optical flow solves stuff like that. We are almost going to finish. Just something else, talking about morphing. So the algorithms works very well, but sometimes works too much. What I mean? I mean that, for example, if I say hi people, well, the sound of my hi, maybe it comes from a portion of text that is not similar to this, not so close to the sound of the H that comes from another condition. Because in 6 minutes, people can change the tone, can change the expression, how it works. And so, even if you use optical flow, could happen that the movements of your lips are not so smooth because of the fact that that the reconstruction is too much accurate. So what I did is to skip some frames and using morphing in order to make the animation much smoother. But what it means, morphing, I guess that the morphing technique needs no presentation, but is not a computer vision morphing. So it's not just moving pixels, because that could lead to a bad artifact. We leverage a very, very special feature of the deep learning and in this case of the autoencoder. And so what we do is to do morphing on the latent code of my model. So if I want to reconstruct some skipped frames, I use the encoder. I extract the source, the starting Latin code, skipping, for example, 2, 3, 4 frames, extracting the end, the destination Latin code of that input, and I do interpolation of the Latin code, creating the corresponding frame. That makes an amazing reconstruction of a very, very accurate reconstruction of my final frame. And this is something magic, really. It works great. Well, what could happen? Could happen that if you skip a fixed number of frames, maybe you cut some important frames and you don't know that. So I used an API that is in beta so far, come from Microsoft, that was created for something else. But anyway, that API that extracted the VCM information of my audio and provide in a JSON format the information with the timestamp and the corresponding sound phonema where is in my audio. And so with simple calculations, I can predict where to skip in a very accurate way. And it could happen that, for example, at the beginning, I have to skip much more frame based on how fast I talk and how the word is it. And after, maybe I need no skip, and after again, I need to skip two frames instead of 3 frames and so on. So I suggest to put one eye on this amazing API coming from Microsoft. Well, finally, we created the infrastructure on Azure cloud, and we used the streaming services and Azure Media Services to for the streaming service. And of course, we added a DRM protection for the video that we generated. One of the best architecture solution was to use the Azure Bot Framework for our chatbots. And the idea is that once there is a reply from your NLP engine, of course, this reply is in a text format. That text is sent to our API, to this service, that in batch already created this video, and it plays the rendered video close to your chat, speaking, talking about the sentence that you want. Of course, the sentence that is associated to your reply. So I guess that we have no more time. Anyway, this is the list of all services that we used, and this is the final result that we are going to release, how it should be. So I guess that is everything. I don't know. Yes, we should be in time.
Yes, Sebastiano, thank you very much. It was very interesting, very informative. We'll be waiting for some questions from the attendees. I kindly urge you to post your questions in the Q&A section. Meanwhile, I'm going to ask you a
Yes.
question. Are you using at the moment this model for some business cases, or it's just a project so far?
Yes, of course, because hey, you know, the best of software in the world is useless if it's not sold. So we
Yeah, yeah.
created this product so far, and so but we are going to use this kind of technology also for other products. As I told you at the beginning, for example, to create much more attractive landing pages. So
Hmm.
for example, Google campaign, you can land into this web page, and it's the avatar that there is the avatar that is in the interactive and then start engage you against
Hmm.
standard landing pages where must be the final user that have to find the way to engage with you. And so we hope that this technology will boost this business.
Thank you. Do you think do you think that this is the future of the helping bots on the sites?
Yes, because not just because of our studies, but we realized, and also other people, other researchers, that people are much more accustomed to talk with something, even they know that is not real, but they are much more accustomed to talk with something like that than typing into a chat where they already know that behind there are robots, not
Hmm.
so smart. And we realized that this approach is a really game changer, mm, to boost the interaction with the users.
Yeah, so it's already used, and I guess they are seeing more and more customers coming to the sites and interacting.
So I'm not able to see very well, sorry.
Yeah, I'm going to read it for you.
A significant amount of
From
similarities in common. Ah, the question is if there are similarities with classification in computer vision. I guess could be true for half. I mean that if you split the model in two parts, the encoder and the decoder, the part of the encoder is the same of a classification problem. Yes, in this case, but from the decoder, of course not, because the decoder reconstructs the image and takes also the audio as input. So with these changes is has nothing in common with the classification, but the encoder part, yes.
Okay, Tefik, thank you for the question,
Anyway, again,
the
feel
answer.
free to write to me, and I will be happy to share my knowledge about this project. So by email, LinkedIn, I will be there.
Thank you for your availability, Sebastiano. I guess there are no more questions so far. Um, we can wrap it up, and everybody who wants to find out more about that great work, that great project, could easily contact Sebastiano through the different social channels. Thank you, everybody, for your attention, and I hope to see you in the next session. Thank you, Sebastiano, once
Thanks
again.
for the invitation. Bye.
Thank you. Thank you. Bye bye.